students. Myself, Dr. Divya, Assistant Professor at the Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, we will discuss the methods that are used for controlling the corrosion. So, the outcome of this session would be understanding the corrosion control methods and the mechanism of its reaction in protection. So, let us go into the topics. Here are the topics. We will have a glance on what is corrosion, as we have seen the corrosion in the previous session. Then why corrosion control is required, why we really require to control this corrosion for the metals during industrial applications or daily applications, and what are the different methods for controlling this corrosion, and in that cathodic corrosion and mechanism of this cathodic corrosion and its types. Then surface coatings, that includes organic coatings, inorganic coatings and metallic coatings. So we will go in detail one by one in understanding. So what is corrosion? Corrosion is nothing but the degradation of material, as we have already studied. It indicates like the metal will always follow a backward step or the backward reaction to form a stable, to get a stable form. So this corrosion is an extractive methodology in reverse. Like it means when we do metallurgy, like extracting metals in reverse, if it is done, the metal will go back to its original form or the ore form. So it is a spontaneous reaction. So the driving force for this reaction is the tendency of metals to have a lower energy. So at its stable form, or the ore or compounds, when a metal is forming, it has stable form with lower energy. So as we see from these figures also, this aircraft, the propeller is corroded a lot. And there is always a scope like this. It always tends to go to its lower state, but due to corrosion, there is defects in there will be defects forming in the metal, and it will cause damage to the part of that particular metal. So these are some of the examples. So we will see why we really require corrosion control. Not only industry, there are several other applications for any metals or other parts or alloys that are used. So for example, in dental medical field, we use it for the implants like dental or stents that we use for the blood vessels. So when we use metal that is corroding, so if they get corroded, that will cause damage to the human body. So it will affect the health in a lot of manner, because it will be bleeding. And for example, it is also used in the surgical instruments, implants, pacemakers, etc. So we should take care of the metals that should not corrode. So metals has to be controlled in corrosion. So ultimately this will affect the economic aspects also, because we are investing some money in implanting metals on the human body or any other industrial applications. So the other examples are like monuments. For example, as we see this Statue of Liberty is brownish colored, turned to greenish due to oxidation reaction, nothing but corrosion. So these are some of the examples. And also some factories, for example, if the machinery is getting corroded, then it will affect the production of that particular product. So also the building materials in engineering, civil building in materials, if the metal is corroded, it will delaminate from the structure. So that will affect in the constructions. So these are the some of the problems that we are facing due to corrosion. So we require corrosion to be controlled. So what are the different methods in controlling these corrosions? There are several methods that are used. So some are cathodic protection, then surface coatings. So we will see in detail what is cathodic protection or the surface coatings. So what is cathodic protection? The protecting metals or alloys from corrosion, making them a cathode. So when the metal is becoming cathode, what is that? It doesn't undergo oxidation, so it will be protected. So that is the main concept behind for making it cathodic. So to achieve this, auxiliary anode is provided in the corroding medium. So for example, if the medium is like a solvent, like water or sand or something else like landfills, then what happens? We will be providing anode, so that the our metal of application will become cathodic, and therefore it will be protected. So this is of two types again: sacrificial anodic method, impressed current cathodic method. So we will see in detail what are these two methods of cathodic protection. So in this cathodic protection, we will be forcing the metal to act as a cathode. So the metal to be protected from corrosion is connected to more anodic metal. So in sacrificial anodic protection, the name itself indicates that sacrificial anode. It means the metal whatever we are connecting will become an anode that sacrifices itself and protecting a other metal which is in application. For example, as we see here, the ship hull, which is made up of steel, is connected with sacrificial anode zinc blocks. So the steel is connected. Steel is nothing but iron alloy. So steel is connected with sacrificial zinc blocks which undergoes corrosion. So here zinc undergoes corrosion and protects steel and protect steel. So this is how the anodic protection is done. Sacrificial anodic protection is done. So mainly the common metals used are magnesium, aluminium and zinc, and their alloys for protecting the other metals. So the same thing is projected in this figure. See, as we see here, this is the sacrificial zinc anode that is placed, and this is the metal, iron or steel that is present. So this will be sacrificed, and the whole boat or the ship will be protected from corrosion. So this again, one more example is like these anodes consisting of highly reactive metal like magnesium. For example, if magnesium is taken as an example of magnesium, then it is connected to protect wire pipes. For example, this is the pipeline underground pipeline. So we are using magnesium anode for protecting this iron pipeline. So rods of magnesium buried near the pipes and connected them by wires. So we will be placing these magnesium rods beside this pipeline, and we will be protecting. Thus, galvanic cell with high EMF are set up with surface to be protected, made cathodic. So this is how a high EMF is developed, so that it becomes cathodic in nature and therefore protects. So the cost of replacement of this cathodic. So when magnesium rods are placed, we have to replace them periodically, so that the original pipeline will be protected. But if we see this, the replacement cost is lower. So this replacement cost of this magnesium is lower when compared to the original pipeline that has to be replaced. So this is good in protecting the original pipeline. So the other method is the impressed current method, wherein the impressed current is applied in opposite direction to nullify this corrosion. So how is done? It convert the corroding material from anode to cathode. So current is passed. So for example, the impressed current is higher than the corrosion current. The current or the energy that is released during corrosion is less, or the impressed current is higher. Applied impressed current is higher compared to the corrosion current. Therefore, it will make the corroding metal to be cathodic. So if we see an example, as we see here, there is a protective anode placed here, and the pipeline that is here that to be protected. So if we apply current, this is the current source. So if we apply current, it is flowing like this, and this will be getting protected. So this is how the pipeline is protected from corrosion. So the impressed current is taken from either from battery or AC line. So this can be either battery or the alternate current line. So that can be used for many applications like water tanks or oil pipelines or water pipelines or transmission towers, so on. So this gives a very good example where current can be applied in protecting the our original application of that pipeline. Then comes the surface coatings. So surface coatings, there are many coatings that are used. So surface coatings are basically two types like non-metallic and metallic. And in non-metallic coatings, there are organic coatings and inorganic coatings. So the main function of this coating will be a barrier that is created between the atmosphere and the metal. So we see that there are a lot of paints that are used, for example. So these paint will act as a barrier between the atmosphere and the metal. There are many methods that can be used. So metallic coating, inorganic coating and organic coating. So this coating will act as sacrificial anode or release substances that will inhibit the corrosion. So it will release the substance that will inhibit the corrosion on the substrate. For example, as we see, the man is coating the aircraft. So he is coating with a paint. This paint is nothing but, so it becomes a sacrificial anode and it will protect the base metal. So examples are paints, drying oils or varnishes, synthetic clear coatings. These are some of the examples. So we will see in detail one by one different different coatings and their applications. So metallic coatings, for example, a base metal is present that is used for many applications like screws that we use for machineries. So this base metal can be like iron. Iron is the base metal. So if there are different types of coatings. It can be either noble or the cathodic coating or anodic or sacrificial coating. So when depending on the application, we will be using these type of metallic coatings. So for noble or cathodic coatings, what happens? There is no reaction. It means inert metals or noble metals are used like silver, copper, nickel, chromium, tin and lead are used on steel. Steel is nothing but alloy of iron again. So metals with higher electrode potential than base metal is coated. If we remember that galvanic series, noble metals are placed below. So it means they have higher electrode potential than the base metal. It means there is no oxidation reaction that is taking place for these noble metals. So cathodic coating protect the base metal only when coating is uniform and free from porous. So whenever we coat with noble metals, that has to be uniform and without porous, only then it will help in avoiding the corrosion. So the other one is the sacrificial or anodic coatings, wherein zinc, aluminium and cadmium is used to coat steel. So electrode potentials of zinc, aluminium and cadmium are lower than the iron or the steel. So these are used for the cathodic anodic coatings. So anodic coatings protect the base metal sacrificially. It means it will undergo corrosion. The coating that is being applied will undergo corrosion and will protect the base metal. So the applications are like different modes of applications are present. The methods, that is like hot dipping, flame spraying, cladding, electroplating, etc. So these are some of the methods that are used for depositing the metal coatings. So one of these is the hot dipping. In hot dipping, what happens? It is the most widely used control method for corrosion. So it produces a coating having low melting point. Why low melting point? Because we are dipping in a hot solution. It means it should have low melting point metals. So what are those? Zinc, tin, lead and aluminium on iron. Iron is having high melting point, so it doesn't get dissolved or dissolution into the solvent that we are using. So the metals that we need to coat should have low melting point so that it gets coated onto the iron or the steel that is used. So on steel, copper having high melting point. So for example, we will see in detail how the dipping will be taking place. It has two different methods, like galvanizing and tinning are the two methods or the modes of application. In galvanization, what happens? Iron article is coated with zinc. So zinc is used in coating the iron articles. Iron or steel is cleaned with pickling sulfuric acid. What does this pickling method do? Like when it is dipped in sulfuric acid, it will be cleaning the surface without it, so that it removes the dust particles. So it is done at 60 to 90 degrees centigrade. So this is the bath having the sulfuric acid, H2SO4, sulfuric acid at 60 to 90 degrees. So in this, the metal or the article, iron or steel is dipped. So what happens? It will undergo cleaning, like dust particles or can be removed, and then it is passed through a washing bath containing water, so that it will rinse the metal or the steel. Then it is dipped in the molten zinc. So here is a molten zinc. Before that, drying, it goes through the drying chamber. Drying chamber, we supply hot air, because when temperature increases, it will dry quickly. So in hot air, it gets dried and again dipped into the molten zinc at 425 to 450 degrees centigrade. At this temperature, the surface of the metal will get corroded. Will get coated with the zinc. The surface of bath is covered with ammonium chloride to prevent oxide formation. Why we are using ammonium chloride? Because the bath will be covered with ammonium chloride, so that the zinc will not undergo oxidation by trapping oxygen from the atmosphere. So that is also a very important step to be considered. Then the excess zinc is drained through a hot pair of rollers. So as we see from this figure, see there are rollers that are placed after dipping into the molten zinc. There are rollers placed. So passing through these rollers, the excess zinc will be drained into this bath. So this is how we do the coating of zinc on the steel. So what happens after that? We will be annealing. Annealing is a heat treatment process. Heat treatment. At this heat treatment process, the deposited metal will be adhering to the steel or the iron and becomes annealed. So this is the method we use for coating zinc onto the iron or steel. Then is the tinning process. Tinning is nothing but coating of tin onto the steel articles. So process of coating tin over steel articles. This is called tinning. Why? Because tin is noble metal and is more resistant to chemical attack. So it is more resistant to chemical attack and provides cathodic protection. This is also a type of cathodic protection, wherein it is very resistant to the chemical attack and therefore becomes a cathode. Iron sheet is treated with sulfuric acid to remove any oxides. So this will help in removing the oxides. So for example, if we have an iron sheet or bar, then we will be treating with sulfuric acid and remove the oxide layers if any present. Then this clean iron sheet is then passed through a bath containing zinc chloride flux. So this is this flux is nothing but zinc chloride. Then followed by this molten tin. This is nothing but the sheet that is rolling through the flux into the molten tin, and then with the oil. Then with the vegetable oil, passing through the vegetable oil. So all this process will take place and help in adhering the metal. So this zinc chloride helps molten metal to adhere to the base metal, and then palm oil protects against from corrosion. So this is how tin is being coated onto the steel articles. For example, these are some of the applications that we used for the food industry, packing. So it is very important to take utmost care in coating the tin onto the metal, because it is used for the eatables. Then are the inorganic coatings. These inorganic coatings, like as we have seen, these inorganic coatings comes under non-metallic coatings. So what happens here? Inorganic coatings can be produced by chemical action. Chemical action with or without electrical assistance. It can be like a simple chemical process wherein the metal will be coated onto the metal, or the uh, metal will be coated onto the base metal. So the treatment changes the intermediate surface layer of metal into metal oxide, or the compound which is better corrosion resistance than the natural oxide that is present on the metal. So for example, there are cement coating, glass coating, ceramic coating, or chemical conversion coating. So these are some of the example. For example, if we see, this is the ceramic coating. As we see for the automobiles, ceramic coatings are used. Anti-dust coatings, they act as anti-dust coatings. So if there is no coating, this is how the dust will be accumulated. But if there is a coating of ceramic coating, then there is no accumulation of dust on the automobiles. Then chemical conversion, anodizing, phosphatizing, or chromate. Chemical conversion, here we will be using chemical solution which is converting the metal nature. So this is an example before cementation, and after we will see in detail in the next slide how the process will take place. So in this cementation, it is a type of precipitation reaction. There is a precipitation reaction that is going on. So heterogeneous process in which ions are getting reduced to zero valency, or the metallic state. Zero valency is nothing but the metallic state, and it forms a solid metallic interface. So the copper ions, for example, copper ions in the solution are precipitated out of solution on solid ion. For example, if iron is dipped, this is copper sulfate solution. If iron is dipped in this solution, then copper is deposited on the iron bar. So this is how the coating will be taking place. So the reaction is copper 2 plus ions will reduce to copper 0 valency, that is a metallic form, and Fe plus 2 ions. So this method is mostly used in metal extraction, like industrial recovery of heavy metals, including cadmium, because it is very hazardous. Before throwing into the atmosphere, we have to recover the metals. And then cementation of gold by zinc in Merrill-Crowe process. So these are some of the applications where cementation process is done. Then metal cladding. In this metal cladding, the surface of the base metal that is used in the application, like iron or steel, is coated with metal cladding method, wherein it is sandwiched between two other coat metals. That is sandwiched between two thin layers of coat metal and pressed between rollers. So this is rollers. This is a roller. Again, this is a roller. So here is the duraluminum. So it is already written, duraluminum, that is sandwiched between two other metals and pressed in a roller. Between rollers. So the metal coat must be anodic to the base metal. This will be anodic to the base metal, and only plain surfaces can be cladded. For example, only the sheets, like plain sheets, can be cladded using this method. So this method is used for coating aluminium, chromium, nickel, and duraluminum. These are some of the examples where this type of metal cladding is used. And all corrosion resistant metals like nickel, copper, silver, gold, platinum, and all the alloys are used. So these can be again used for the metal cladding process. So alloys like steel, nickel can be used as cladding materials. So duraluminum is a lightweight material that is used most widely used in aircraft manufacturing industry. So which is cladded with aluminium to get alclad. So this is an example where we use duraluminum, which is a lightweight material in the aircraft industry. So then electroless plating. So if you see the other application, the mode of corrosion resistant coatings is the electroless plating. It is an autocatalytic chemical technique. So it is an autocatalytic chemical technique wherein without the without the electricity, we can coat the metal with other metal. It is used to deposit a layer of nickel phosphorus or nickel boron alloy on a solid workpiece of metal or plastics. Because we are not applying any current, even plastic can be coated with this type of method. So the process relies on the presence of reducing agent. So the most important thing is the reducing agent that is considered, because only this will allow the metal to form metal from ions to reduce to metal. So it all depends on reducing agent. So example is hydrated sodium hypophosphite reacts with metal ions to deposit metal. Here if we see, these are nickel coated bearings. Nickel coated bearings. So it does not require any electricity for electroless process. Electroless plating, no electricity is used. Electroless plating, no electricity is required through the solution to form a deposit. So this requires only the reducing agent, that is important. So that is how we can be able to deposit even on the plastics. So this prevents corrosion on wearing of the metals. So what are the advantages of this electroless plating? It does not use the electric power. Then even coating on the parts can be achieved. No sophisticated jigs or racks are used. Then flexibility in plating volume and thickness. So we can coat even very less coatings, which is a tedious process in other methods. However, electroless process can produce even very thin coating of the metal. This process can plate recesses and blind holes in the stable thickness. So blind holes, even if we have some holes, it can deposit metal and give thickness. Even conformal coating of that metal. So chemical replacement can be monitored automatically. Then complex filtration method need not be done, because it will be purifying, and it only requires reducing agent that is used for the deposition. Then matte, semi-bright or bright finishes can be obtained. So depending on the reducing agent, the concentration or the volume, we can vary the brightness of the finishes so that it allows the coating of that metal. What are the disadvantages? Lifespan of the chemicals is limited. For example, if we use a chemical for electroless process, the lifespan of that, for example, it will be it can only be used for some less days, so that again the chemical has to be replaced for the next coating. So the lifespan is limited. Then cost treatment is high, because for example, if we are unable to use the chemical that is in the bath, we have to waste treatment has to be done before sending it to the drain. So the waste treatment is high. Only the two disadvantages that is present for the electroless plating. Then are the organic coatings. So organic coatings are nothing but that gives a barrier between the atmosphere and the base metal. So if we see, there are automobiles or aircrafts or the fencing, these are some of the application. Fencing, automobiles, cars or aircrafts that are being painted. So organic coatings are paints that are used. So coating liquid generally consists of solvent, resin and a pigment. So these consist of a solvent, a resin and a pigment. The resin provides chemical and corrosion resistance. This resin will act as a chemical and corrosion resistant, and pigments may also have corrosion inhibition property. So examples are like paints, varnishes, lacquers, etc. So these organic coatings are chemically inert to the atmosphere environment. Environment is nothing but oxygen or carbon dioxide that is present. So whenever we send the aircrafts into the atmosphere, It exposes to various humidities or temperatures, the dust particles or oxygen, so it should be inert. So these coatings are inert enough to protect from the corrosion. So gives good adhesion. Surface adhesion, we will see what are the different materials that will be used in adhesion. Then impermeability to water, gases or salts. So when we are using for different, for example, fencing will be exposed to different environments in different seasons. So it has to be impermeable to water, gases or salts. These are some of the properties. So a paint, for example, paints are used. If we take an example of paint, it acts as a protective layer for the surface to prevent corrosion. So what does a paint contain? These are some of the constituents of paints: pigment, vehicle, thinner, dryer, filler, plasticizers and anti-skinning agents. So we will see in detail one by one what are these and how are these used, why are these used into the paints that are used for coating of that metal. So pigment is nothing but a solid constituent that obscures the surface and provides decorative color. Pigment is nothing, for example, we have a beetroot, carrot, they are colored because of that pigment. Even the paint has a pigment. So pigment plus binding media will together form a paint. So that is nothing but a color giving substance. Liquid that binds the pigment to the surface and protects from decay. A liquid binds this pigment. So this is a liquid that is used as a binding agent and protects the surface from decay. So usually 60 to 80% of the weight of the paint film consists of this pigment and increases the life of paint film since it protects from ultraviolet rays. Any type of pigment has a reaction with ultraviolet rays because of high energy. So these increases the life, the base metal life will be increased because the paint is exposed to these ultraviolet rays and protects from the corrosion. Example is lead oxide, red lead and lead chromate. These are some of the examples of pigments that are used in paints. Pigments that are used in paints. Then is the vehicle. What is the vehicle? That is used for coating this paint. So film forming constituent of the paint is nothing but vehicle. Like oils, they hold the pigment on the metal surface. This will help in holding the pigment or the paint onto the metal surface that we are coating. So they give metal adhesion to the metal surface and they impart durability and toughness to the film. So if it is more adherence, when it has more adherence, it will give toughness and durability to that film. They isomerize, polymerize and condense to form characteristic tough, elastic, coherent and highly cross-linked structures or macromolecular film. So for example, these are having some macromolecular structure. So oils has structure, so that will form with pigment. So this is a binding agent. Binding agent will combine with the pigment and forms a big structure that will help in increasing the durability of that paint. Okay, so examples are mustard or sunflower oil. So we will see the next one, what we are using in paint. Thinner is nothing but, as we see from paints that we use in painting our houses also, thinners are used for painting. So mixing in the paint and then we use using. So this will reduce the viscosity. If the paint is very thick, then depending on application, we can thin the paint. Thin the paint. So reduces the viscosity with addition of thinners. So it is no volatile solvent. So it will also adjust the consistency of the paint, and being volatile, it will be evaporating. Being volatile, it will evaporate immediately after painting the metal surface. So they remain permanently in the paints and vanishes, and it will improve the elasticity of the film. So when the viscosity, it will reduce the viscosity and also increases the elasticity of that film. Then they suspend the pigments in the paints, so it will help in mixing or suspending the pigments into the paint. So examples are turpentine, mineral spirits, xylons, kerosene, etc. These are some of the thinners that are used in paints. Then fillers. What are fillers? These are some inert materials that used in the paints, so that will improve the properties of the paints. So they also reduce the cost of the paint, and these are generally used to fill the voids of the film. So for example, if we have a metal surface and there are some voids, then applying the fillers along with, when applied with filler plus paint containing fillers will help in filling the voids. Voids are nothing but spaces in the film. So it will increase the random arrangement of pigment particles. So the pigment particles that are suspended in the paint, the arrangement can be increased by fillers, and also improves the durability of the film. So examples are like talc, chalk or silica that are used as fillers in the paints. So then dryers will help in drying the paint. So nothing but oil film. Drying of oil film that is present in the paint can be improved or increased or accelerated in the presence of dryers. So these are nothing but, it will increase the drying capability of that paint. To reduce the drying time of a dryer is added. So it will also, like for example, if a paint without dryer, it takes 5 minutes, and with the dryer it will take only 2 minutes. That is how it will accelerate the drying of that particular paint. So they are oxygen carrier catalyst that acts as an oxygen carrier catalyst, so that it will be drying, and improves the drying quality of the oil film. And this is done by condensation, oxidation and polymerization reactions that will be taking place and helps in drying. Examples are linolates, borates, resinates. These are some of the chemical compounds that are used as dryers in the paints, helps in drying. So these we see commercially used dryers for the paints. Then plasticizers and the anti-skinning agents. What are plasticizers? They are present in the paints and vanishes. They will increase the elasticity. I mean the brushing capability, brushing of paint. So elasticity, improve the elasticity of the film. So when we are applying paint, it should have the elasticity so that it will be spreading smoothly evenly onto the metal surface, and also prevents the cracking of the film. It also prevents the cracking of the film. Anti-skinning is nothing but remove when there is peeling off. For example, if we see in this figure, if the man is able to peel the film, so it should be anti-skinning property. It should have the anti-skinning property. For that we will be using triacryl phosphate, triphenyl phosphate, dibutyl tartar. These are some of the examples that are compounds examples that are used in as anti-skinning agents that are mixed in paints for obtaining anti-skinning property. So whenever there is if we see there is peeling of metal surface or the paint on the metal surface, it means it is devoid of these anti-skinning agents which are not mixed, and therefore the metal is getting the paint is getting peeled off. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.